the operation point of the DC motor, okay, which works on the principle of whenever current carrying conductor placed in the magnetic field will experience a force. What is that? F? F is equal to Bi into L, okay, into sin theta. Because if you are considered, if you are taken maximum displacement, then obviously that sin theta will not be considered. B is the flux density, I is the current flowing through the conductor, L is the length of the conductor, okay, in terms of meter. Then what is the force which it is exerting? Always perpendicular to each other, corresponds to that of magnetic flux. Then obviously which will make sense towards the production of mechanical energy. Okay, as per the Fleming's left hand rule, we can find the direction of the rotation. Okay, that Fleming's left hand rule is that thumb will represents the thumb, forefinger, middle finger have to hold perpendicular to each other. Then direction of forefinger is the magnetic field. Direction of middle finger is the direction of current. Then direction of the thumb indicates the direction of force exerted. Okay, this is what the Fleming's left hand rule. Okay, in your PU level, you might be studied this. Okay, you have to remember that is also. Then back EMF. Okay, this is new to you. Okay, in case of DC motor, there will be a N pole. Okay, there will be a S pole. Then armature conductors are placed in magnetic field. Isn't it? Whenever this carried a current, then which will produces the mechanical energy. But whenever it is rotating, is this flux cut by this conductor? Yes or no? Once it started rotating, is that flux will cutting this conductor? Anybody? No reply. Unmute by yourself, you can answer. If the conductor is rotating in a magnetic field, is that possible to cut that magnetic flux or not?
No, sir.
Why no, pa? Because conductor is placed in magnetic field, na? Then obviously which will cut that magnetic flux. Because current carrying conductor placed in the magnetic field, it starts rotating. If the conductor is rotating, that flux are cut by that conductor. Whenever flux linking with respect to that conductor changes, then obviously there will be induced EMF. That induced EMF in case of the DC motor is itself is called as back EMF. EMF induced in armature conductors cut by the main magnetic flux of the main pole in the DC motor is called as back EMF. In case of generator, generated EMF. Okay, but which will always opposes to that of applied voltage because it is the cause produced by the applied voltage. Okay, obviously according to the Lenz's law, which will opposes to each other. Okay, then whatever this back EMF is there will have helps the DC motor to self-regulate. It means that proportional to the torque developed, then it will rotate at a particular speed. Okay, that is the what be meaning of self-regulating, which will acting as a speed controller. Okay, the back EMF will control the speed of the DC motor. Okay, there will be three conditions. According to that, the operation which will be taking place. Okay, one is whenever the motor is not having any load, then a small amount of torque is produced. Okay, then to reduce that one, the friction loss or the windage losses, then the sum amount of the back EMF has to be produced. Because of that reason, which will run at maximum speed. Whenever you applied a load, then what happens? The motor will be slowed down by the armature. Why? because EMF induced in the conductor will be get increases. Because of that reason, the amount of the torque, whatever which is to be get produced, will also be get affected. Due to that reason, the back EMF will be get reduces because of the decrease in speed. Then with that decrease in speed, then obviously which will control the torque, so that the sufficient amount of the torque will be get produced by the load, what is to be applied by the use of back EMF. Hence, the back EMF will control the speed based on the application of the load. Okay, whenever the load is get decreased, then what happens? The speed is get increased. The armature will be get accelerated. Then obviously EMF which it is induced in the armature conductor will also be get increases. Why? Eg equal to pi ZNP upon 60. If the speed increases, EMF increases. If the speed decreases, EMF decreases. Okay, that is the what? The speed regulation to be get controlled by the use of what? The back EMF itself. Okay, practice this. This is very important. What do you mean by back EMF? What is its significance? One is no load condition. Then another one is increasing load. Then third one is decreasing load. Okay, these three conditions you have to explain. Okay, then the back EMF itself regulates the flow of current, then automatically which will control the speed. Okay, this is with respect to the what? The back EMF and its significance. Okay, this is also be important for the examination point of view. Then classification of the DC motor. Okay, but in case of DC motor, okay, there is no separately excited DC motors. Okay, always the DC motors are of self-excited type. Okay, the practically we are not using it, but the separately excited DC motors are available, but practically we are not using. Based on that practical usage, the DC motors are divided into three types. Okay, one is series, shunt, and compound. Okay, in compound again, the short shunt and the long shunt. As you are discussed in case of the DC generator, in the same way, there will be series motor, shunt motor, compound motor. With respect to the compound, short shunt and the long shunt. Okay, based on that additive nature and the subtractive nature, differential compounded and the cumulative compounded motors are also be available. Okay, you can see here with respect to the series motor, field winding is connected in series with respect to the armature. But instead of the power generation, what happens? We are providing the power supply input, because which will convert electrical energy into mechanical energy. Then back EMF will opposes what? Applied voltage. So that I equal to, okay, whatever the current is there. Okay, that is I equal to ISC into IA. What is V? Terminal voltage, EB, IA into RA, then ISC into RSC, then brushes drops you considered V brush. Okay, then with respect to that V, IA and ISC are same. IA into RA plus RSC plus brush drop. Okay, these equations also you remember, because for the problem solution we are going to use it. Okay, in case of the DC series motor, then armature current passing through the series field winding, okay, will be equal and same. Then what happens? The flux produced is proportional to that of armature current. Pi is proportional to ISC, which is proportional to IA. So that on no load condition, the DC series motor never be run. Okay, this is the concept. Then with respect to the shunt motor. Okay, with respect to the shunt motor, what happens? Field winding is connected in parallel to the armature. Voltage is applied. IL equal to IA plus ISH. ISH equal to V by RSH. V equal to EB plus IA into RA plus brush drop. But what is flux produced is directly proportional to the shunt field current. Okay, this is what the shunt motor itself. Remember formula. Once I am practicing the problem, then you are understanding what logic it is present. Okay, always if the field winding is connected to the armature parallel, then it is called shunt. If it is connected in series, then it is called as series. Then next is short shunt and the long shunt. Okay, here also what happens? Series field is connected in series with respect to the parallel combination of armature and shunt field winding. IL equal to ISC. Okay, IL equal to IA plus ISH. Then ISH is equal to V minus ISC into RSC divided by RSH. V equal to what? EB plus ISC into RSC. Then IA into RA and the brush drop. Okay, V minus ISC is equal to what? Okay, if I take this side, then obviously that is EB plus IA into RA into brush drop. Okay, this is with respect to the short shunt. Then with respect to the long shunt, what happens? Whatever the series field is connected in series with armature, then that combination is parallel to the shunt field. Okay, this is the series field and armature is connected in parallel to the shunt field. Okay, that is called as long shunt. Here we are going to apply the voltage V. Okay, then IA equal to ISC, then EB equal to pi ZNP upon 60A, then IL equal to what? IA plus ISH, then ISH equal to what? V divided by RSH, V equal to EB plus IA into RA plus RSC. But with respect to that, IA and ISCs are equal to each other. So that IA into RA plus RSC plus brush drop. Okay, this is what? The long shunt compound motor. Okay, here only the formula you have to remember. Practice these equivalent circuits. Then you can capable to understand. Okay, and series motor should never be started without load. Why? Okay, this question also be most commonly repeating in the examination. Okay, that is the motor armature current is dependent on load. At light load or no load, the armature current drawn is very small. Because if there is no load, current will be smaller. Obviously, if the load is applied, then current will be get increases. If the current is small, as the speed is inversely proportional to the flux. Okay, if current is less, what is the flux? Flux is also be minimum. If the flux is minimum, what is its speed? Speed is maximum because inversely proportional. So that at light load condition, the series motor will run at dangerous speed or the higher speed, so that it may damage the motor mechanically. So that without load, the DC series motor never be run. So that to avoid this one, the DC motors are get connected to some external load or the belt drives to break that torque. Then obviously which will reduces the dangerous speed to be operated on no load condition. Okay, this is the what? The condition for the DC series motor should not be run on no load condition. Okay, this is what with respect to that of the series motor itself. Okay, next last topic of the today's class, that is torque equation of the DC motor. Okay, what is the torque equation? First we need to understand what is torque. Turning or the twisting force due to the interaction of two magnetic flux is itself is called what? Torque. Okay, you might be learned in your PU also. Okay, this is the torque. That is the perpendicular distance which will have experience a force over the circumference. That's also be called as torque. Okay, that also you can able to define in that way also. But with respect to the DC motor, that is circular in nature, which is having a radius R, then which will experience a force F. Okay, so that which is to be represented radius R, force F, which is acting tangentially. Okay, then what is the torque which is to be get exerted by the force F? Okay, it is the product of force into distance or the radius. TA, armature torque, is equal to F into R. Unit for force is what? Newton. Then distance is what? Meter. Newton meter is the unit for torque. TA is equal to F into R. Okay, then what is the work done which is done by this force for one revolution? That is force into distance. Okay, amount of force into distance covered by particular time duration. Okay, we are considering the one revolution. For one revolution, 2 pi r, because we know that length. Okay, it is a circular, so that 2 pi r, that is work done. W is equal to F into 2 pi r. This is in terms of watt second. Okay, then what is the power developed there? Okay, that is force into speed. Okay, whatever it is to be present. So that I can get with respect to that of power developed, F into 2 pi r into number of revolutions per second. That is F into 2 pi r into n divided by 60. Okay, then 2 pi n I will take here. Okay, 2 pi n divided by 60. What is F into r? That is the torque, armature torque. Okay, that is the TA. Then power developed is equal to 2 pi into n into TA divided by 60. Okay, but in previous class we have discussed that is the power developed is equal to induced EMF into armature current. In case of DC motor, what is induced EMF? That is the back EMF. EB into IA itself is the power developed. If the power developed is equal to this equation, then the power developed is equal to this equation. Is these two are equal now? So that EB into IA equal to 2 pi n into TA divided by 60. But what I want, actually I want the armature torque. Okay, so that TA equal to 1 divided by 2 pi into Z into IA into P by A. That is the Newton per meter. But this 1 divided by 2 pi itself is what? 0.159 pi Z into IA into P by A. This is the what? The torque which is to be developed by the motor. That is the armature torque. Okay, once you go through this derivation, okay, this derivation is also be important for the examination point of view. Okay, nothing is there, only the multiplication and substitution. Okay, if the complication is there, that I will do in my class. Okay, if not, not required. Okay, if you are getting any doubt regarding to this, you can ask my offline class. Then I will resolve the same thing. Okay, then there will be two torques. Okay, one is shaft torque, then the armature torque. But the shaft torque itself is the output of the motor in terms of watt divided by 2 pi n into 60. Okay, this is what the shaft torque which is to be get developed. Then the difference in this armature torque and the shaft torque is itself is called as lost torque. Okay, that is TL equal to TA minus TSH. Okay, this is with respect to the what? The armature torque which is to be get developed in case of the DC motor. This is also be most important for the examination point of view. Is this clear?
Yes, sir.
Okay, with respect to the DC motor, remember working principle. Whenever current carrying conductor placed in a magnetic flux which experience a force. Then types of DC motors, series, shunt, compound. Field winding is connected in series with field, that is armature, then it is called as series. If the field winding is connected in parallel to the armature, it is called shunt. If the series and shunt field both are present, it is compound. Then back EMF, the EMF induced in the armature conductors of the DC motor, which is to be get produced because of the flux cut by the conductor. That EMF itself is called as back EMF. What is the function of back EMF? Which will regulate the speed. Under no load condition, okay, the speed of the motor will be rotating at a rated speed. Then proportional to that, the torque will be produced. Second thing is that whenever the load is applied, speed is get reduced. If the speed is reduced, voltage will be get reduced. If the voltage is get reduced, then torque developed by the motor will also be get affected. Then third case is what? If the load on motor is get decreases, again it is get accelerated. Speed of the motor will be get increases. If the speed of the motor is get increases, then a back EMF will also be get increases. If the back EMF is get increases, proportional to that, the torque have to be developed. in order to control their speed. So that the function of back EMF is to regulate the speed. Then fourth point is what? That is series motor never be run on no load condition because N is inversely proportional to pi. If the flux is low, speed is high. So that on no load condition, current is small, flux is small, then which will run at dangerous speed. So that the series motor never be run on no load condition. Okay, the next topic is fifth one is torque equation of the DC motor. The turning or twisting force of the machine which will produced by the interaction of the two magnetic field is itself is called as torque. Okay, that is the force into distance. Then according to that, the power developed by the machine is itself is 2 pi n upon TA, that is 2 pi n into TA divided by 60. Then with respect to the electrical parameter, EB into IA, when you are equating that is TA equal to 1 divided by 2 pi into pi Z into IA divided by P by A, which is equal to 0.159 pi into Z into IA into P by A. P is number of poles, A is a number of parallel paths, IA is the armature current, Z is the armature conductors, pi is the flux per pole. Okay, then this is the what? Armature torque. Okay, then there will be a shaft torque, that is the output power of the motor in terms of watt divided by what is the revolution which is to be rotating, that is 2 pi n divided by 60. Then I can get the shaft torque itself. Then last torque is what? The difference between the shaft torque, that is armature torque, and the shaft torque. Okay, the problem we'll discuss that, nothing to worry. Okay, the problem with respect to the DC generator and the DC motor. Okay, those are also be important for the examination point of view. Okay, whatever the practical diagrams and the equivalent diagram I have explained there, once you can go through the notes, okay, if you are getting any doubt, then you can approach, okay, then I can recall the same, nothing to worry.